This is part 3 of the Python Secret Tips series. Okay, here we go. Queues are a fundamental data structure that follow the first in, first out principle. They're useful in various scenarios such as task scheduling and managing resources in concurrent programming. Queues can be implemented using lists in Python. Here is how to use a list. Just use the standard list append method to push elements to the queue, which is also sometimes called enqueue operation. And to dequeue items from the queue, just use pop method.
Our objective is target queue pledges.
Python's standard library has a module called queue, which provides a thread-safe FIFO implementation. This is particularly useful in multi-threaded applications where multiple threads need to communicate with each other. First, instantiate a queue, then use put method to enqueue the elements, and use get method to retrieve from the top of the queue. This method will block if the queue is empty until an item is available. If you don't want to wait, you can use the getNoWait method, which will raise queue empty exception if the queue is empty. If you are using multiple processes instead of threads, you can use multiprocessing module, which provides a queue class that is similar to the queue.queue class, but is designed for inter-process communication. In the following example, we create a worker process that takes items from the queue and processes them. Then, in the main process, we add items to the queue and wait for the worker to finish. This is not possible with queue.queue because it is not designed for inter-process communication.
Wait a minute, there's a queue here.
Priority queues are data structures that allow you to manage a collection of items with associated priorities. Items with higher priority are dequeued before items with lower priority. These are commonly used in scheduling, for example, to give higher priority to more important tasks. The most efficient way to implement a priority queue in Python is to use the heapqueue module, which provides an implementation of the heapqueue algorithm, also known as the priority queue algorithm, which supports insertion and extraction of the smallest items in O log n time. Use heappush to add items to the priority queue. The first element of the tuple is the priority, where lower values indicate higher priority. Then you can use heappop to remove and return the item with the highest priority. List comprehensions are mad. Although they are simply a syntactic sugar for loops, they can make your code more readable and concise. For example, the following code creates a list of squares of even numbers from 0 to 9. This can be rewritten using a list comprehension. The if part is optional. You can also use list comprehension without it, which is equivalent to the following. List comprehensions can also be nested. For example, the following code creates a list of tuples representing the Cartesian product of two lists. This can be rewritten using a nested list comprehension, like this.
You're meddling with powers you cannot possibly comprehend.
Similar to list comprehensions, Python also supports set and dictionary comprehensions. Set comprehensions use curly braces instead of square brackets. This code is equivalent to the following. Dictionary comprehensions also use curly braces, but they require a key-value pair separated by a colon, like this, which is equivalent to the following. In Python, any object can be made iterable by implementing two dunder methods, iter and next. This can be useful when you want to create a custom object that can be iterated over using a for loop or other iteration contexts. For example, you can create a simple iterator that generates the Fibonacci sequence. You can then use this iterator in a for loop. A more concise way to create iterators is by using generator functions. A generator function is defined like a normal function, but uses the yield statement to produce a series of values over time, instead of returning a single value and exiting. Each time the generator's next method is called, the function resumes execution from where it last yielded a value. Here is how you can create a Fibonacci generator function, and here is the result of the execution. Similar to list comprehensions, Python also supports generator expressions, which provide a more memory-efficient way to create generators. A generator expression is similar to a list comprehension, but uses parentheses instead of square brackets. Here is how you can create a Fibonacci generator expression. The major difference between a list comprehension and a generator expression is that the former creates the entire list in memory, while the latter generates item on the fly, and thus is more memory efficient for large datasets. Python does not have a built-in switch statement like other languages, but you can achieve similar functionality using dictionaries to map cases to functions or values. This can make your code cleaner and more maintainable compared to using multiple if, elif, else statements. Here's an example of how to implement a switch-like behavior using a dictionary. How this works is first, you define the functions for each case and a default case. Then you create a dictionary where the keys are the case values and the values are the corresponding functions. The switch case function takes a case value, looks it up in a dictionary, and calls the associated function. If the case is not found, it calls the default case function. Whether it's an anti-pattern or not is debatable, but it is a common and accepted practice in Python to use dictionaries for this purpose. It can lead to cleaner and more efficient code, especially when dealing with a large number of cases.
Must be a bad switch.
Python has several ways to merge dictionaries. Here are some of the most common methods. Using the update method on the dictionary itself, which modifies dict1 in place and overrides any existing keys with values from dict2. Since Python 3.5, you can also use the double star syntax. This method creates a new dictionary, merged dict, and does not modify the original dictionaries. It also overrides any existing keys with values from dict2. Since Python 3.9, you can also use the pipe operator. This method also creates a new dictionary and does not modify the original dictionaries. It overrides any existing keys with values from dict2. You can also use the chainmap class from the collections module. This method creates a new view over the dictionaries and does not modify the original dictionaries. It does not overwrite existing keys, but rather provides a way to access values from multiple dictionaries. Each of these methods has its own advantages and disadvantages, so you should choose the one that best fits your use case.
Just look up the word handsome in the dictionary.
When working with dictionaries in Python, especially large ones, it can be helpful to pretty print them for better readability. The built-in pprint module provides a way to do this. Here's an example. The pprint function formats the dictionary in a more readable way, with indentation and line breaks. When you want to print list items in a horizontal line instead of the default vertical line, you can use the unpacking operator star along with the print function. Here is an example. You can also use a syntax where with the sep parameter to specify a custom separator between the items, for example a comma space, which achieves the following result. Python has a built-in calendar module, which can be used to pretty print calendars for a given month or year. Here is an example of how to use it. I'm going to print a calendar for the 6th month of year 2024. You can also print the entire calendar for a specific year, something like this. To get the current date and time in Python, you can use the datetime module, which provides various classes for manipulating dates and times. Here is how to get the current date and time. You can also format the date and time in a more readable way using the strftime method. For example, to get the current date and time in the format year, month, day, hour, minute, second, you can do the following. You can also get just the current date or time using the date and time methods respectively. You can sort a list in reverse order using the sort method with the reverse parameter set to true. Here is an example. It's important to note that sort only works on lists, not on other iterable types like tuples or sets. If you want to sort a tuple or set, you can convert it to a list first, sort it, and then convert it back if needed. In Python, you can swap the values of two variables in a single line without needing a temporary variable. This is done using tuple unpacking. Here's how you can do it. You can count how many times a specific item appears in a list using the count method of the list itself. This method returns the number of occurrences of the specified item. Here is an example. Of course, you can do that in a manual loop. However, this is much more compact. If you have a nested list, a list of lists, and you want to flatten it into a single list, you can use list comprehension. Here is how you can do it, and here is the result. If you want to find the index of the largest or smallest number in a list, you can use min and max function along with the enumerate function. Here is how you can do it. How this works is really interesting. The enumerate function adds an index to each item in the list, creating pairs of index value, like so. Then, min and max functions then find the pair with the smallest or largest value based on a second item in each pair, which is the actual number from the list. The key parameter in these functions allow us to specify what we want to compare based on the second item of the pairs, which is the number. And finally, we extract the index, which is the first item of the pair, using the indexer operator. That's it for now, but there will be even more tips, so please like and subscribe if you want to see the next part produced in near future. Thank you for watching.